Okay, so we're gonna find the vertical, horizontal, and oblique asymptotes in any original function, if there have any original function. Okay, so this one I'm doing page 197, question 40. So the question, the problem. So we're trying to find if there's any vertical, horizontal, or oblique asymptotes. What? Negative 2x squared 2 plus 1 divided by 2x plus 3 plus 4x squared. Okay, so we're gonna simplify all this. So it's gonna be 1 minus 2x squared over 2 divided by 6x2. How do I got that? Because this 2x plus 1, what is it? So it's gonna be negative 2x and 4x. So it's 4 plus 2. What is 4 plus 2 equals 6x, and then square over this one. So simplify that. So that's gonna equal negative 1/3. So x equals a positive infinity number. So that's the horizontal asymptotes. So it's the horizontal asymptotes. And this one. Okay. So the vertical asymptote is 1 minus 2x2. So it's the same problem as this one. We're just gonna find the vertical, x2. So that's gonna equal infinity, like this one. So it's gonna equal x equals 0. So there is a horizontal and a vertical, but there is no oblique asymptotes because none of these are greater than or less than it. So there's no oblique asymptotes. Okay, so we're gonna find the vertical, horizontal, and oblique asymptotes if any of which rational functions. So I'm doing page 197. This is problem 49. So the problem is rx equals 3x4 plus 4 x divided by x3 plus 3x. So to find if it has a vertical or horizontal asymptote, so it's gonna be, so we're gonna do x over 3 plus 3x equals 0. So that's gonna equal x squared plus 3 equals 0. So that equals x equals 0. So, or you can do x2 plus 3 equals 0. So however, x2 plus 3 equals 0 has no real numbers, real solutions. So therefore x equals 0. So is only a vertical asymptote. So it's not a horizontal asymptote. Okay, so does it have an oblique asymptote, and if any of each rational function? Okay, so it has no horizontal asymptote because the degree of the numerator polynomial is greater. This one is greater than that the denominator, so denominator is this one, denominator polynomial. So that's why it doesn't have a horizontal asymptote. So now we're gonna find the oblique asymptote if the degree number is one higher than that degree of the number, and use long division to find it. So we're gonna find long division, so we're gonna do this. So this, you have to divide it by this, so it's gonna be x3 plus 3x, and this is long division, okay? And it can be confusing. 3x4, so it's 3x4 because it's this, so we're dividing that, and then plus 4 over here on the side. So first we're gonna do this, so we're gonna subtract. So this 3x4 goes into 1, so that's gonna be 0, and then minus x2 because we square root it, okay? So that's gonna be negative 9x2, and that's gonna be over here 3x. So that's plus 4, right? So that's negative 9x squared. So when you square root this, it's gonna be y equals 3x, because it's the same thing, like 3 times 3 equals 9. So same thing as this, it's 9. So y equals 3x is the oblique asymptote. So we're gonna find again the vertical, horizontal, and oblique asymptote if it has one, or the rational function. So this one is page 107, question 15. So it's rx equals 6x squared 2 plus x plus 12 divided by 3x 2 minus 5x minus 2. Okay, so we're gonna find if it's a vertical or horizontal. So we're gonna solve it. So it's 6x2 plus x plus 12, x minus 2, and 3 plus 4. 3 plus 1, sorry. Okay, so then we're gonna simplify it. 3x2 minus 5x minus 2 equals 0. So that's gonna be minus 6, no, sorry. So it's vertical asymptote x minus 2 and 3x plus 1 equals 0. So it's on this one, right? So that's gonna be x equals negative 1/3 and x equals 2. So we're gonna solve it. 3x2 minus 6x plus x minus 2 equals 0. 3x x minus 2 plus 1, x minus 2 equals 0. So then we simplify this, x minus 2, 3x plus 1 equals 0, right? So none of these are greater, none of these are, all of them are equal. So the horizontal asymptote is n equals 2 and m equals 2. So y equals 6, square root of 3, 2. So there's no oblique